Dear friend, I have come with a very interesting example for the deflection calculation for a beam at a tip which is subjected by a uniformly distributed load. This is a cantilever beam and we need to find delta B, which is deflection of beam at B, and it will be solved using moment area method. And this is our lecture third, in which we are going to find out deflection at point B. But in our lecture 2, second lecture, we have solved same example, same length of cantilever beam having UDL, but that was solved using unit load method. And I want to show you review of the same lecture that was the problem statement: calculate deflection at a tip of a cantilever beam which is subjected with uniformly distributed load W throughout its length. Load is W, length is L, and delta B was calculated using unit load method. And deflection calculation value was calculated as WL to the power 4 divided by ATI. It was the calculated value. You can go through the entire lecture to understand how we have used unit load method to find out deflection at point B. Now we are going to solve this example using moment area method. So we have to understand what is moment area method. Before calculating delta B using moment area method, we need to understand the statement of moment area method. Moment area method states that area of M over EI diagram multiplying with centroid of this M over EI diagram will give deflection at any point. So for calculating deflection, we have to solve two parts, and I have to follow two parts separately. First, we have to generate a M over EI diagram, and second part, we have to find out centroid of this M over EI diagram. First part, before deriving M over EI diagram, we need to develop bending moment diagram, that is M diagram, or you can say bending moment diagram. For the cantilever beam, which is subjected with UDL the entire length of this beam, it is very easy to find out bending moment, and you can easily understand how it can be generated a bending moment diagram. You can see here the problem statement is: this is the beam having UDL W, span is L, and we need to find out bending moment diagram for this beam. Therefore, we need to first find out bending moment at any section XX for this beam. Suppose this is the section XX, which is at a distance of X from the tip of this beam. Tip of this beam is B. You can say there is a section XX from point B. So we need to find out a general moment at a section XX. The general moment will be MXX. MXX is nothing but M, bending moment. Okay, that will be the general bending moment. Now, as per our assumption, anticlockwise moment will be negative. Now, we need to generate a bending moment at a point at a section XX. The length of this length from point B to XX is X. So multiplying with W with X will give the load. You can say take its enlarged view. something like this. This is W. We have a section, section XX here, and section XX is at a distance of point B, this point B, this point A, this is X. Now bending moment will be MXX. That means bending moment at section XX. MXX, or say M, will be equal to load. W multiplying with this X will give a load. W, it is UDL, means uniformly distributed load. It is in unit of kilonewton meter or newton meter or kilogram meter per meter. Here we have taken it kilonewton per meter. In Spain we have taken in meter. So kilonewton per meter multiplying with meter, meter will get cancelled. We will find kilonewton, which is a unit of load. So if we multiply W in this part from B to section XX and multiply with this X, that is the length, will give a load. So W into X will be the load, which will be acting at a distance X by 2. X by 2 from section XX, and load value will be Wx. This is the load. For length X. For length X, it is a total load, and total load multiplying with distance X by 2 will give a moment, and we can write this value here. Now, and we have assumed anticlockwise moment is minus negative, so we can use negative sign. With Wx is the load multiplying with the distance will give a bending moment x by 2, so value will be minus Wx square by 2. This is the general bending moment we have developed at a section of XX from point B. So bending moment at A will be MA. For that, X will be, for MA, X will be equal to L. So moment A will be equal to minus W divided by 2. In place of X we put L whole square equal to minus WL square by 2. It is the maximum bending moment at point A. So bending moment diagram will be this one. This is the length of this beam. This point is A, this point is B, and bending moment profile will be this. Its maximum value will be WL square by 2. As bending moment profile is following a curve which is parabolic in nature, this is following, it's a function of x square, so it is a parabolic curve. So we need to generate a parabolic curve for this bending moment diagram. It is in parabolic in nature. Parabolic curve. This is the M diagram, or you can say bending moment diagram. Now we need to find M over EI diagram. Just we have calculated M diagram. We can represent it as something like This is length L. Maximum value at point A is WL square by 2. Support moment, it is negative hogging moment and it is in anti-clockwise directions. So now, and this is parabolic. This is M diagram. Respective M over EI diagram will be M over EI diagram means every y coordinate will be divided with a value of constant value of EI, because EI is constant, E is elasticity, I is moment of inertia. So EI is flexural rigidity. This is constant for any structural member. Constant for any structural member. Okay. Now, if we are dividing with a constant value, the profile will be same, but somehow this coordinate value, if suppose this value and this value, it will be lesser than this value. So somehow our value, the profile will be same, but the y coordinate will be somehow lesser than this M diagram. So M over EI diagram, this is M over EI diagram, M over EI diagram, M over EI diagram, and this value will be WL square by twice EI. We have divided WL square by 2 divided by EI. So the maximum value in M over EI diagram will be WL square by twice EI, and length will be same. X coordinate will be same for any coordinate division by dividing by EI. So the curve will be same. It will also a parabolic curve. Parabolic curve of function x square. Now we have to find area of M over EI diagram and centroid of this M over EI diagram. Now we can separate out M over EI diagram. This is our M over EI diagram. Length is L. Value is WL square by twice EI. Function is x square, which is a parabolic curve. Now, for any parabolic curve, the area will be area of this M over EI diagram. This is the M over EI diagram. Area of this parabolic curve will be 1/3 multiplying with this length with height. Length is L, multiplying with WL square divided by twice EI. So its value will be WL to the L cube, WL cube divided by 6 EI. This is the area of this M over EI diagram. This is what we can say. This is area of M over EI diagram. area of M over EI diagram. Now for calculation of delta, calculation for centroid x bar, that will be centroid value will be somehow here. This is x bar from the point B. This is point B and this is point A. X bar will be 3/4 of this length. 3/4 of this length L. Now, so x bar will be 3/4 of this length L. We have directly used area of this parabolic curve and centroid of this curve. We will give you the general formula to find out area and centroid of any curve which may be a function of x square, x cube, x to the power 4, or any kind of to the x to the power of n. Any kind of curve you can find out with this general formula. You can find out centroid as well as area. Now we can go with this one. Area calculated for M over EI diagram is WL to the power 3 divided by 6 EI. X bar is 3/4 of this length, total length. So delta B will be this one multiplied by this one. So WL to the power 3 divided by 6 EI multiplying with 3/4. Now 3 divided by 6 equal to 2. It will be W. This will be 3/4 length. W L to the power 4 divided by 8 EI. Hence we can say delta B will be W L to the power 4 8 EI, which is deflection at tip of this cantilever beam which was subjected with uniformly distributed load, and we have calculated this delta B at tip of this beam using moment area method. Moment area method. So now we need to, as I have told you, I am going to give you a general formula, general expression to find out centroid and area of any curve which might be of any function. You can take any curve. For example, there is a x coordinate and this is y coordinate. If your curve is showing something like this and the function of this graph y is a function of x to the power n, and this is length L, this is height h. So keep in mind area of this graph will be 1 divided by n plus 1 multiplied with length multiplying with height h. Now for example, if y is a function of x square, maybe it's a parabolic x square that we have solved in this example. As we got a parabolic curve is a function of x square in our example. So in place of n we can put 2, as this is a general curve x to the power n equal to 2. So area will be 1 divided by 2 plus 1, and it will be L and it will be h. So 1/3 of L into h. For calculation of area we have taken this 1/3 same. We have taken length L is same, and it was H. H was WL square by twice EI. So in our example, we have calculated area for a parabolic curve which was in the shape function of x square, and this value was WL square by twice EI. So we have taken area as 1/3 of this is length L into WL square divided by twice EI. So we got WL cube divided by 6 EI, which we have done here. WL cube by 6 EI. Now for centroid, the general formula for centroid for this kind of curve is x bar. X bar will be n plus 1 divided by n plus 2 multiplying with L. This span is L, and this is it's a function of power n. So n plus 1 divided by n plus 2. For example, if we take our example, we have solved for a cantilever beam with a UDL at the entire span, and we found that its bending moment was a function of x square. So we can take the same here. In the case of n, it will be 2. So we can say x bar will be 2 plus 1 divided by 2 plus 2 multiplying with this length L. So it will be 3 divided by 4. 3 divided by 4, it will be x bar. And we have done the same thing here. We have taken x bar equal to 3 by 4L. If you remember this two formula, you can find out any kind of area or any kind of and its centroid using this formula. Same thing, if in case of point load, you will find bending moment will vary as a function of, it will vary linearly. It will be something like this one. If it is a point load, suppose it's a beam, fixed cantilever beam, and it is subjected with point load P, its span is, its length is L, maximum moment will be PL. Okay, and this is a function of x, and here n equal to 1. So you can say area will be 1 divided by n plus 1 L into H. Here it is PL and this is L. So 1 divided by, here n equal to 1 plus 1 L into H. In place of H you can say P into L. It will be 1 by 2 L into PL. This is the area of a triangle, half length into PL. This is the area of triangle, and as linearly varying curve, it will form a triangle. So we can see our general formula is correct. In the same way, centroid will be what? You can also check it. This is a centroid, suppose x bar. For centroid, as we have as I have given you a general formula of this one, x bar will be n plus 1 divided by n plus 2 into L. In this case of linearly varying graph, or for a graph which is directly proportional to x, n will be 1. So in place of 1 n, you can use 1 plus 1 divided by 1 plus 2, and this is length L. So 2 divided by 3, 2/3 of L. So for any triangular shape, centroid is x bar equal to 2/3 of length from this point, but from this point it will be 1/3. Well, this is, if this is h, this is L, area will be half L into h. This is the area of triangle that we have done here. So I hope your concept regarding calculating area of any curve which might be a function of x to the power 2, 3, so on so forth, you can calculate area using this general method, and also its centroid using this general expression. I hope your concept regarding the calculating deflection for a cantilever beam which is subjected by a UDL by moment area method might have cleared. And hope if you find any difficulty on that, you can write in comment box. I will surely reply to you. Thanks for watching. Keep watching and please share to your friends and colleagues. Thank you.